If you recall, last week we were talking about, we finished the week talking about alternating series and conditional convergence. So let's review that idea today and then look at some examples and then discuss why conditional convergence is lesser. Why is conditional convergence inferior to absolute convergence? Why did we name them in such a hierarchical fashion? So the alternating series test states the following. If you have an alternating series, so the way to write down an alternating series is to have a -1 to the n. That's the alternating part. What that means that the rest of it, the an, that needs to always be positive so that the terms actually alternate. If you have an alternating series and the terms decrease and decrease to 0, then the series converges. Remember that the limit of the terms equals 0 is necessary for convergence. What we're getting here is that the terms decrease. The two new things here are alternating and decreasing. Alternating and decreasing. The reason that we want the alternating and decreasing is that so that the sequence of partial sums will do that door spring thing. That will necessarily zero in on the limit of the sequence of partial sums, thus zeroing in on the sum of these series. So limit as n goes to infinity of an equals 0. That's a necessary condition. What we say here is that we have if we have alternating and decreasing, then we get convergence. So of course we need this. This is a necessary condition. So of course we need this. What the alternating series test is really bringing to the table is if the terms alternate and they decrease, then we get convergence. I think I had some wonky numbering last time. So the way we really want to think about this is that if the terms alternate and decrease, then we get convergence. Along with our necessary condition that the limit of the terms be 0. We've met our necessary condition of the terms be 0, alternating and decreasing. Our favorite example of this is, of course, the alternating harmonic series. It converges conditionally, but the alternating harmonic series converges with a finite sum. We have alternating, the terms decrease, and the limit of the terms is 0. So the first thing that we always check, the limit as n goes to infinity of -1 to the n plus 1 over n is equal to 0. That's necessary. So then 1, the terms alternating, and 2, the terms decrease. If we look at 1 over n plus 1, that will be less than 1 over n. Pointing out that the limit of the terms is 0, we could ignore the alternating part. But I threw it in there just because we look at the whole thing first before we decide how we're going to approach the problem. If a series converges, but the series where we make all the terms positive diverges, the series in absolute value diverges, then we say the series is conditionally convergent. So the series itself converges, but the series in absolute value does not converge. Then the series is conditionally convergent. So the alternating harmonic series is conditionally convergent. The alternating harmonic series converges, but if we take away the alternating part, the series diverges. So we can see that alternating, making half of our terms negative, is a very powerful tool indeed. This makes things go to 0 fast enough, because remember, when we're trying to determine if a series converges, we know that the terms need to go to 0. It's not that the terms go to 0, it's how the terms are getting there. And by alternating, by subtracting half of the terms, we get convergence. The alternating 1 over the square root of n series converges by the alternating series test. Let's make sure we make notes of why things are. So this alternating 1 over square root of n converges by the alternating series test. But the series 1 over square root of n diverges. P series with p equal to 1/2. So since the series itself converges by the alternating series test, but the series in absolute value diverges, using the p series, p to the 1/2, we can conclude that the series is conditionally convergent. We needed the alternating series test to get convergence. It's the alternating that makes the series converge. It's the alternating that gets us convergence. It's the alternating part that got us convergence here. This is all sitting in the backdrop of is the limit of the terms equal to 0. And here, yeah, they are. It is. The terms go to 0. It's the alternating that makes sure that the terms go to 0 fast enough. The terms go to 0 and they go to 0 fast enough because they are alternating. In this one, we have this very obvious alternating. The problem here is that the terms don't go to 0. We are not even going to bring up the alternating series test. The alternating series test has one conclusion. If you have an alternating series whose terms decrease to 0, then the series converges. That's it. You would not say diverges by the alternating series test. Because the alternating series test does not contain provisions for concluding divergence. So the problem here is that the limit of the terms does not exist. Therefore, the series diverges. So we notice right away this series diverges because the limit of the terms is not 0. An important thing to note on this problem, the reason that I brought this particular problem up, first of all, the series diverges. That's all we need to say. The limit of the terms is not 0. We are done here. The trap that you want that's set up in this problem is that the limit of the terms is also not -2/5. Because when we have a -1 to the n, when that factor is positive, the terms are headed towards -2/5. When that is negative, they're headed to -2/5. This limit does not exist. So from a technical standpoint, if we want to be technically correct, we don't want to say the limit of the terms is -2/5. So the limit of the terms does not exist. Half the terms are headed to -2/5. The other half of the terms are headed towards +2/5. It doesn't matter that the terms are decreasing. The terms are not decreasing to 0. The alternating part is not relevant here. We never say that a series diverges by the alternating series test. That's not a conclusion offered by the alternating series test. So half the terms are going to -2/5. Other half going to positive 2/5. The important thing to conclude is that the alternating is not a factor here. The alternating does not help us out here. Because the terms don't go to zero, we don't want to even bring up the alternating part. I know I've been sitting here bringing up the alternating part of this series for the last 2 minutes. But the point of bringing up the alternating part is so that in the future, when you come across this series, you don't bring up the alternating part. The court analogy holds here. Like if you were going to court, you don't want to bring stuff up that's not relevant. You don't want to say anything. You don't have to say. So the alternating part is irrelevant here. If you bring up the alternating part, all of a sudden the first major cognitive thinks, do they think that it matters if the series alternates? The terms don't go to zero. Why are they bringing the alternating series? You do not have a proper understanding of the alternating series test. Does that make sense? Since you're in the class, like if you did it in front of me, then I would say, well, why are you bringing it up? I would press the issue, but I wouldn't like, it wouldn't be like a fatal flaw in your argument. I say, well, why are you bringing up the alternating? And you'd be like, well, because it's alternating. I'll say, why does that matter? I think you'll stop and pause for a minute and say, well, I guess it doesn't. Well, then don't say, right? See, that's how the interaction goes. But if I was a cop and you're like, oh, well, the series is alternating, why do you think it's alternating? And already you fucked up. Because if I was a cop, you wouldn't be talking to me. Don't bring up the alternating. Just be like, oh, well, the series is alternating. What do you think of that? I'm not discussing my day. That's it. Any questions? Oh. A little aggressive writing N there. Yeesh. In the category of don't bring up irrelevant shit. If a series converges in absolute value, that is best. The series is absolutely convergent. So the example that we've used before, for example, if we have the series as n goes from 1 to infinity, of -1 to the n plus 1 over n squared, the alternating is once again a ruse, a trap, bait to see if you will bring up the alternating when it's not relevant in this problem. The absolute value of the terms, that series converges. The series converges in absolute value. ignoring the alternating parts, this series, we have a convergent P series. Therefore, we could just conclude that the series is absolutely convergent. The alternating is extra. Since the alternating is extra, we don't bring it up. If you bring up the alternating, it makes the person that you're talking to think that you think alternating series will get you absolute convergence. If you say something like, it's absolutely convergent by the alternating series test, you have demonstrated that you don't understand what's going on. You have demonstrated that you don't understand the alternating series test. The alternating series test just says series gives the conditions under which a series converges. It does not give the conditions under which the series is absolutely convergent or conditionally convergent. Just says convergence. So even if on 2 examples ago with the alternating harmonic series, you wouldn't want to say it's conditionally convergent by the alternating series test. That is once again not understanding the alternating test. The alternating series test just says convergence. It doesn't specify what kind. If I sound like a rules lawyer right now, that's because I'm being a rules lawyer right now. That's because we're trying to understand shit. Question. When you're talking about math, your goal should be to understand and demonstrate that understanding. We demonstrate what's frustrating about math is you demonstrate your understanding of math and you improve your understanding of math by demonstrating your misunderstanding. So it's my job to continue saying, no, that's not it. No, that's not it. Try this. No, that's not it. Did you think about this? Until you you say something, I'm like, oh, yeah, that is it. You know what I mean? That's all. We're just trying to understand the assignment. Speaking of court, my favorite example of people misunderstanding the assignment is that all the Supreme Court justices who sit there and try to discern the original intent of the founding fathers. Thomas Jefferson himself said, we should probably write this shit every 20 years or so. And they're like, oh, what were they thinking? We should enact laws like they had back then. It's like, well, we should not do that. That is exactly the opposite of the intent. What I'm saying is that all the originalists on the Supreme Court don't understand their fucking job. Dumbasses. I'm not even Supreme Court justice. I'm not even a fucking lawyer. And they're the ones that don't understand their job. And I promise you that if I brought that up, someone who supports that line of thinking would immediately come after the fact that I'm not a lawyer, ignoring the fact that this not a lawyer understands the job better than they do. That's embarrassing. The last thing you should do is bring up the fact that I'm not a lawyer. You know what I mean? Also, when they bring up the fact that I'm not a lawyer, that is directly an admission that I must be correct because they cannot come after my argument. They had to come after me. As soon as you're in an argument, when you're in an argument, as soon as they come after you personally, yeah, well, those shoes are stupid. Just say, I accept your defeat. Because you could not refute my argument, so you had to come after me personally. So thank you for conceding defeat. You know what I mean? Funny that I picked shoes and defeat. Don't bring up irrelevant shit. This series is absolutely convergent. The alternating is irrelevant in this situation. It'll change the value that we're headed to over the regular series, the unalternating series, but it doesn't make it more convergent. Better yet. That makes too much of a point. Well, better yet, this also makes too much of a point. See, I'm already falling into the trap of bringing up irrelevant shit. This series has this -1 to the end, so that makes it alternate, right? Clearly, it doesn't because I just said fake alternating, and then I immediately wrote this series down. This series is not alternating, even though it has a -1 to the end. -1 to the end is being multiplied by cosine n, and cosine n is not positive for all n. Furthermore, cosine n doesn't alternate. So, first of all, the series diverges because the limit of the terms is not 0. All right, so this one, we're clearly not discussing this because it's a question of whether it converges or diverges. Limit as n goes to infinity of -1 to the n, cosine n does not exist. Well, specifically, is not 0. That limit doesn't exist. The series diverges. We are done here. As far as answering the question whether it's convergent or not. The point that I want to make here is that -1 to the n does not give you alternating when cosine n is not going to cooperate by always being positive. Cosine of n is a little bit erratic in its positive and negative. So cosine, let's make sure I'm in radian mode. Cosine of 0 is positive. Cosine of 1 is positive. Cosine of 2 is negative because we've gone over into the second quadrant. Cosine of 3 is also negative because we're still in the second quadrant. Cosine of 4 is also negative. So we have positive, positive, negative, negative, negative. That's not alternating. So it doesn't matter that I multiply the first one by 1 and the next one by 0. The terms are positive, positive, negative, negative, negative. And then we're back to positive for 5 because we're back into the fourth quadrant. And we're still in the fourth quadrant for cosine of 6. So the cosine n is not positive for all n. So this series is not alternating. We don't want to bring up the alternating series test, first of all, because the series diverges and the alternating series test will have nothing to do with it. Second of all, it's not even alternating. Just because we have a -1 to the n does not mean that we are alternating. This is a very contrived example because of the cosine n. That's a really weird thing to have, but I needed to make a point. So there it is. So the important thing here is that the series is not alternating. -1 to the n tries to make you think, hey, here's an alternating series. Why don't you use that alternating series test? You're like, oh no, the series is not alternating because cosine n is not always positive. Any questions? This series does not have a -1 to the n in it, but it's an alternating series. It's not relevant because the limit of terms is still not 0, so we don't care. But this is actually an alternating series. This is another way to write alternating starting at positive. Cosine of 0 is 1. Cosine of pi, 1 pi, is -1. Oops, not a sequence. Cosine of 2 pi is 1. Cosine of 3 pi is -1. Cosine of 4 pi is 1. Cosine of 5 pi is -1. The series is alternating. This is just another way of writing -1 to the n. It's an alternate. It's alternating. This series is alternating, but it doesn't matter since the limit of the terms is not 0 because the limit of the terms does not exist. This series diverges. That means it does not have a sum. This is super sneaky because some people will look at this and say, well, obviously the sum is 0 because they'll read it this way. They'll see this 1 minus 1, or I spelled 1 wrong. Because we'll start putting in parentheses that aren't there. But then someone else would be like, oh, no, what if we see it this way? 1 plus -1 plus 1 plus -1 plus 1 plus then the sum is 1. Then the two people are like, oh, I guess we'll have to agree to disagree, and the sum is both, which is stupid because we can't make a sum out of this. Series diverges. You're both being idiots. The series diverges, the limit of terms is not 0. We are not headed towards one value, so we are not headed towards any value. The problem is someone's like, oh, can you explain that to me? It's like, oh, yeah, can you take another couple of math courses up to Calc 2? Towards the end, we'll talk about this in more detail. They're like, oh, no, I don't want to do that. Like, well, I guess we're just going to have to settle on it. Any questions? That is funny because for the most part, any controversies that you can explain to people have been settled a long, long time ago. And any controversies that are kind of still in the air kind of takes so long to explain. Really annoying. Speaking of controversy, I don't know if you've heard, but news broke that a new proof of the Pythagorean theorem using trigonometry has been written and is being reviewed by a few high school students, which is awesome. Even if it doesn't hold up to scrutiny, still a very cool thing. Because for a long time, it was thought to be impossible to use trigonometry to prove the Pythagorean theorem because the Pythagorean trigonometry relies so heavily on the Pythagorean theorem. Every time I talk about trigonometry, the first thing I bring up is the Pythagorean theorem. So it's being reviewed, so in a couple months we'll find out if we have a new proof for the Pythagorean theorem or not. Do watch out for the headlines. The Pythagorean theorem has been proved for a long, long time in many, many different ways. So there are lots of proofs of the Pythagorean theorem. This one just happens to be new. For a long time, it was kind of a hobby of mathematicians, come up with a proof, an original proof for the Pythagorean theorem. Einstein has one. President Grover Cleveland has one. There are many. It's an old theorem, it's well known. This is an original proof using trigonometry, previously postulated to be impossible because of trigonometry's reliance on Pythagorean theorem. So that's really cool news. I know that everybody already knew that because you have your newsfeed aimed right at math. All the math stuff comes right into your newsfeed. All right, tomorrow we want to talk about what makes conditional convergence weaker than absolute convergence. So tomorrow, why conditional convergence is weaker. But that will do it for today. I will see you all on tomorrow. Everybody have a good day. And thanks for playing.